Okay, this lesson is about angles and their relationship with circles. Now there are four basic rules, and each one of them taken individually is relatively simple, but there are lots of complex applications of these simple ideas, lots of corollaries and things such as that. So let's just go through the four, and then we're going to do what is probably the most complex example you'll see, and see if you can follow along and see how it works in a complex example. So here we go. So first type of angle is a central angle. This means an angle that's coming out of the center of a circle. Now the measure of that angle is equal to the measure of the arc that it cuts out of that circle. So that's pretty simple, straightforward. The measure of angle 1 here is the same as the measure of the arc AB. In fact, that's how it's defined. Now, next, we have inscribed angles. Inscribed angles connect 3 points on a circle. So there's 1, 2, 3 points on the circle. They're connected. They create an angle. Well, that angle is half, exactly half, of the measure of the arc that it cuts out. So the measure of angle 1 is half the measure of arc AB. Now we can have other kinds of angles that are formed by crossing either two chords or two secant lines or one or the other, so that you create angles that are crisscrossed inside of a circle. Now whenever you do this, you're really forming 4 angles, but let's just take a look at the pair, this pair here. These two are going to be the same because they're vertical angles. That doesn't matter if they're in a circle or not. That always happens when you cross lines. So the measure of angle 1 and measure of angle 2 are the same. Well, how are they related to the arcs? It's somewhat similar to this. This is half of the arc. In this case, it's the average of the two arcs. So it's half of their sum. So you take AB, which is the arc that 1 cuts out, and CD is the arc that 2 cuts out, and you take the average of those two. So the measure of arc AB, add the measure of arc CD, and then divide by 2 or multiply by 1/2, and that will give you the measure of those angles. So it's the average. Here, it's basically the same idea, except for now we've got an outside angle using either a secant line or a tangent line. And in this case, you look at the two arcs. Here's one arc that's created from A to C, and then there's another arc created on the inside from B to C, but instead of adding, you now subtract. You take the outside arc, which is the largest, and you subtract the inside. So if this is 100 and this is 40, if this arc was 100 and that arc was 40 degrees, you go 100 minus 40 is 60, and then you divide by 2 at the end, just like you did over here. So that would be 30 in that case. So that's how they all work. Here it's just straightforward. The central angle is equal to the arc, the measure of the arc. Here it's half. For an inscribed angle, it's half. For an inside angle that's formed with two cross lines inside, it's the average. You add them and divide by 2. And for outside angles, it's the difference divided by 2. You subtract and divide by 2. And so that's the basic idea. Now, how they get applied in complex things with all sorts of interactions going on, that can be quite complex, and we'll see that next. Using the properties of circles, we're going to do one giant example. From the information provided in this picture, it's actually possible to figure out most, if not all, the angles, arcs, and everything else inside of this image using the properties of angles with circles, as well as a few properties of isosceles triangles that you've learned previously. So let's start with the little bit of information that we're told. One is the measure of this arc here is 80. We've got 2 isosceles triangles. We've got a center mark, so that's the center, which makes this a diameter. And then lastly, we have this outside angle marked at 30 degrees. And from there, we can just go piece by piece. And there's a number of different orders that you could take, but I'm just going to go through, try to make the simplest path possible. So first I notice this is the diameter, which means it cuts a circle in half. And half of the whole arc, half of the semicircle arc is 180 degrees for a semicircle. The whole circle is 360. And so if this part's 80, it means that this part, the measure from A to F, that arc must be 100. Okay, so that's one thing. Another thing is central angles, we just learned, are the same as the arc. And so this central angle that cuts out to AB is going to be an 80-degree angle, and likewise the one that cuts out to AF is 100 degrees. Okay, because they, once again, the central angles are equal, the measures are equal. Okay, well, I'm going to use some properties of an isosceles triangle. This would, since these two sides are congruent, then the two base angles are congruent. Oh, these are vertical angles, which means that they're congruent. Remember, all the properties you've learned so far with angles still apply. And so another isosceles, that means that that's 80 degrees. Well, since I've got 3 angles in a triangle, I've got to add up to 180. I need this to be 20 degrees, and likewise up here, 20 degrees, so that the, what am I trying to say? That the angles inside of a triangle add up to 180 degrees. Okay, and from there we can keep going. Here I've got an inscribed angle. If I go from F to B to E, that's inscribed. It hits 3 points on the circle. Well, I know that the arc is twice as big as the angle. Or the other way of saying it, the angle is half as big as the arc for inscribed. So that must mean that the measure of arc EF is 40 degrees, because it's 20 degrees for the inscribed angle. So you can start to see we're starting to pile up here some information. Well, we can keep going. There's some extra things here. If you notice, this is 80. Across from it must also be 80, because it's a vertical angle. A lot of vertical angles in this picture. But if you look at that intersection, that's an intersection of a line that goes from C, of a chord that goes from C to A, and one that goes from B to E is what forms those angles. And so those are inside angles. Those are angles formed by 2 crossing lines inside of a circle. And how you find out what those angles are is to take the average of the 2 arcs they create. Well, we already know what those angles are, so we're going to work backwards. 80 degrees is the average of the 2 arcs. Well, what's the top arc? So the top arc here is AB. We already know what that one is. It's 80. And so then the bottom arc right here is from E to C. And we know that the average of this arc and this one has to be 80. Well, if that one's 80, then this one has to be 80 too for the average to be 80. So that from E to C, the measure of arc EC is equal to 80 degrees. Okay, so you can see we're starting to really move around. Now, if this right here is 40, and from E to C is 80, and this is a half of a circle that adds up to 180, well then 40 plus 80 is 120, which leaves 60 degrees. So the measure of arc BC is 60 degrees right here. Okay. Now we can keep going. You can see that these are supplementary. It creates a line, so that's 100 degrees, but I could also have done it a different way. I could have done it this way. This angle is inside. It's created by 2 lines that are inside. So I would take the average of this arc, which is 60, and then this big arc over here, which is the 100 and the 40. So 140, take the average. 140 plus 60 is 200. Half of that is 100 degrees. It works out. Okay, so which also would mean that this one is 100 degrees as well. And that one, and that one. So sorry, I had to take a pause because this one's a little bit more challenging. Remember that if it's on the outside, it's the half of the difference. So in this case, and I'm going to try to highlight so you can see, I know this figure is complicated. So 30 degrees cuts through, here's the outside arc from here to there, because you got that line and that line, that's what it cuts. And then you've got the inside arc, and let me use a different color. That starts from here, goes to there. Now, here's the problem. We only know one part of one of those arcs. We don't know both of them. So what I'm going to do is I'm going to call the orange one X. Okay? Now, from E to C, I do know that. I do know what that is. That is 80. So that means that this section right here is 80 minus whatever X is. So here now we have a formula here that the measure of the outside angle, which is 30, let me find a place to write this, so 30 is equal to half of the difference. So the outside one is this green one, which has 60 plus what's here. So 60 plus 80 is 140 minus x, because that's part of that there. So this whole arc is 140 minus x. And then I subtract this inside one, so I'm subtracting x. And here we actually have a formula here that has one variable we can solve. So I'm going to do that very, very quickly. So first I'm going to simplify what's on the inside. So 1/2, 140, there's minus x is minus 2x. Okay, I'm going to distribute. So 30 is equal to 70 minus x. All right, so sorry for the cut there. We're going to finish. Someone just ran into the room, and so I needed to stop. So here we go. We got to finish this off. Well, let's subtract 70. Subtract 70. We have x, negative x, is equal to negative 40, which means that x is 40. So that this arc, the measure of arc DE, is 40. And over here, 80 minus 40x would mean that this arc here, the measure of arc CD, is also 40. Now, let me erase a few things. You can always go back in the video to see what happened. Here's the deal. This kind of problem is one of the most complex types of problems I could ever dream up. But I want you to see that it used all simple ideas. That we found out what this angle was because of what that arc was. It's a central angle, they're equal. We found out what this arc was because we had an inscribed angle over here, and it's just double. We found out what this angle was. We found out two ways, but one of the ways we found out was taking the average of this 60-degree arc and this 140-degree arc, and the average of that is 100. And down here was definitely far more complicated, but if I were to give you it in reverse right now, and I were to take that away, well, now the green arc is 60 plus 40 is 100. So that's 100, and the orange one is 40, and you subtract them. 100 minus 40 is 60, and then half of that would be 30. And that's how for outside angles. So those four ideas are all in there, and if you can understand this, you're going to have no problem whatsoever. And feel free to ask questions as you're doing them in class, because this is simple, but as you can see, when it gets to a big picture like this, it can be pretty complex.